Good morning, everyone. I'm Ujjwala Namaneni. Today I'm going to present about Chicago food inspections, data, and everything. So the problem overview is due to the interest in food and how I got interest in this data set, and this data set is from Chicago Data Portal. It is analysis of food inspection in Chicago State, Chicago City, in various food outlets like restaurants, etc. The project's main goal is to analyze the data and to predict the result of the inspection, like whether it is pass, fail, or pass with some conditions on. And the data description is it consists of like 2,34,319 rows and 17 columns. So the data is from 2010 January to present. I took the data in April, so it lasts from it will be till April. So and the data link and the data set link is attached here. So the doing a EDA analysis, I do some modifications like um, removing some unnecessary columns from like DBA name, which is also there is no need of this column because there is already exist one original name column. So yeah, out of using these insights or like graph from this, I got like more than 50% of the data in Canvas inspection type, and majority of them are restaurants, and some other information like a large amount of data is in high risk category, which you can see in the like detailing in the graphs the following. So this is the first graph which I plotted using risk data, using risk column and the count of it. So most of them are like about 72% of them is high risk, and the second one is the top 10 distribution like inspection types. In that, Canvas is the like more than 50% of the inspection type is Canvas, and count I mean plotting using facility type and count. Most of them are like restaurants, like most. So majority of the data you can consider majority of the data is from restaurants, and among that 50, like most of them are from Subways, Dunkin Donuts, and etc. And coming to the results, which is the major column in this, it's a target column, and comparing with the count of it, we got like most of the columns, like more like so much amount of the columns is like pass one, and few are fail, and some are like pass with conditions, and there are some other columns which are like minorities in this. So we majorly focus on the pass fail and pass without conditions with conditions. So and doing some other analysis like types of risk in like particular months, such that we can understand better about it. So we did like through month, yearly, and so we got like and the second one is using latitudes and longitudes. We plotted. So most of the data is from Chicago. So if you see this in the USA map, you can easily figure out that most of the data is in Chicago area. So this is a plot of it, and here the like most of the blue part is in pass percentage. So pass percentage is more, and this the risk. Most of them are like red color, which is like risk high risk one, and comparing results count with year like year by year wise from 2010 to 2022. Yearly most of the data is passed, but eventually it's decreased, and passed with conditions also increased, particularly we can see in 2018, 19, 20. So and then the from using these insights, I got a feeling that there might be a dependency in the risk from to the columns risk and results. So I plotted the graph for risk and results. So most of the pass percentage is from risk one high, uh, and then the selection, this leads to me to select the feature column, which is risk. And then after modeling, you can see here the accuracy is 0.6 or 60%, but the thing is it does not predict any like there is no precision or recall in case of fail. So it only we can predict few. If it is passed, then only you can predict, and that too with to the certain extent. So I have chosen other feature column as violations. So, and the violation column is most of the thing is like a feedback. So it is in a string format, it's a sentence format. So I had to break down and do encoding for that. So I got some results for that. Rest for testing scores and training scores, like testing is like 87%, training is like 99%. So by doing to do that, I did some model evaluations to the starting of the model evaluation. I just break down the data into training data and test data, which is like 3:2 ratio, or I call like 0.4 or 40% of the data is test data and remaining 60% is the training data. I use like logistic regression, decision tree classifier, and random forest classifier of doing models. And first and later I use like one versus one and one versus rest. So coming to logistic regression and decision tree model, I got an accuracy of 0.6 or 60% before hyperparameter tuning, and 85% for decision tree. After hyperparameter tuning, I got like just a bit increase, which is almost similar, same as before, which is like 59.6% or approximately 60%, and 85.9%, which is approximately 86%. So there is a slight increase in decision tree, but in decision tree model, but not in logistic regression. And then I used like random forest classifier. Let's to see whether there is a betterment in the accuracy. So I chosen this model. So I got an accuracy of 85%. After hyperparameters tuning, I got 87% for this, and later I used one versus one, one versus rest. So I got like 93% macro I mean 90 for ROC, AUC scores, and 94 for one versus rest, and 94 and 95% respectively for weighted by prevalence. So findings. So the feature column will be violations is the feature column, and using this data after hyperparameter tuning, the random forest classifier has the highest accuracy, which is like 87%, and followed by decision tree classifier of 86%, and logistic regression of 60%. Test score prediction score is 87%, and test train score prediction is like 99%. And then challenges. As I said before, I face a challenge in finding the feature column, which is like finding which is the best, which is the correct one, like from risk and violations column. So eventually, I get to know the violation column is the one because of the highest accuracy, and we can predict easily from using the data. Dealing with the columns, which are like almost all, like every column is a categorical column, so dealing with the it is bit difficult, and modeling and finding the best model to improve the accuracy of the prediction. So first we started with I started with logistic regression decision tree, and then eventually I get to know that random forest classifier is having the accuracy more in this particular situation. And then I use one versus one versus rest, so the accuracy increased. And in conclusion, using this model, the inspectors can easily predict the fail pass percentage pass of the particular restaurant or something. So that there will be decrease in chances of visiting the each location, like each restaurant. There will be so many franchises, or so the restaurants count will be more. So visiting every particular restaurant will increases time and consumes more, so that there will be reduced decrease in the visiting. And then also using this data, the owners of the restaurant or particular food outlets will get to know the result by predicting, and so they'll take some safety measures to, like, the quality wise, ambience wise, so there will be decrease in the failure of the result in the inspection, and also the quality of the food increases, and so ambience also will be good, and therefore the model detection of inspection results and improves the quality of food. So these are the references. Thank you.